In this lesson, we are going to talk about special right triangles. And this is something that you learned or saw in a geometry class, the 30-60-90 and the 45-45-90. So this ends up being a huge piece of what we end up doing in this class. We're going to be evaluating all sorts of trig values, and the idea is to not use a calculator. The directions are going to ask for exact values, and so decimals are not okay. Some of you may have heard or will see in the future, or you've seen in the past, this idea of a unit circle. I don't do it. A unit circle, 80% of what I need out of a unit circle is going to come from these two triangles. So if these two triangles, it's pretty much all I need, with a little bit of other information to fill out about 80% of that unit circle. And then there's the other way to create the other 20%. So this ends up being huge. So we're going to do a very, very small snippet, just with some acute angles, some angles between 0 and 90, of trying to find some exact values. All right, and then we'll get into the bigger ones later. So a quick refresher on 30-60-90. So back in your geometry days of this, you figured out that there was a relationship, a proportion between your sides on these two triangles. So across from the 30, everything kind of builds across from the 30, and this was an x, and this was a 2x, and this was an x root 3, right? Now, that's great, but we're not going to make bigger or smaller 30-60-90s. We're not going to be doing kind of the proportions that if this was 5, this would be 10, this would be 5 root 3. We're going to try to take the easiest 30-60-90 we can, because we're going to do sine, cosines, and tangents. So even if you did 5 and 10, when you do sine of 30, it's going to simplify down to the exact same fraction every time. So we're going to make it easy. We're going to make this a 1. So if we make this a 1, the hypotenuse is twice that, so that becomes a 2, and this just becomes a root 3. That is about the easiest 30-60-90 that we can make, and so why not use that one? Your 45-45-90 had the similar kinds of relationships, where this was an x, and an x root 2. So we just make this a 1, 1, root 2. All right, so we are going to try and find exact values. All right, so we'll start off by doing sine of 30 degrees. So sine of 30 degrees is something that, as long as I can draw these two triangles, I can do a whole lot of these things without a calculator, without memorizing a table or anything like that. So sine of 30 is just SOHCAHTOA type of stuff. So SOHCAHTOA is sine's going to be opposite over hypotenuse. That's it. You can type it in a calculator. It's always going to be 0.5, 1/2. All right. So if you were to do a second one, let's say you did sine of 60. Sine of 60 is opposite over hypotenuse. So you'd have a root 3 over 2. So that's the exact. Your calculator, if you were to plug it in, is going to give you some decimal, but that's the exact answer. So that's the non-calculator idea of this. Could you do tangent? Of course. So let's say you did tangent of 30. If you were to do tangent of 30, tangent is opposite over adjacent, so tangent of 30 is 1 over root 3. And then we just got to clean that up a little bit. We have to rationalize our denominator, so we'll multiply top and bottom by root 3. So that's going to get us a square root of 9, which is 3, and then 1 times root 3 is root 3. So that's the cleaned up version. So if you really ever want to check and make sure that you're right, type that into a calculator, type that into a calculator. Those decimals should be exactly the same. Type that into a calculator. That decimal should also be the same. So all three of these are equivalent. A couple more. What if you needed to do secant of 60? So secant of 60, personally, I think of secant. I know that secant is the reciprocal of cosine, so I really kind of think of this as cosine of 60. So I do that work first, and then I get an answer for this, and then I just do the reciprocal to get the answer for this. So cosine of 60, cosine is adjacent over hypotenuse, So cosine of 60 is going to be 1 over 2, which then makes secant the reciprocal of that, which is 2 over 1, which can be just written as 2. All right, let's do one more. Let's do cosecant of 45. So similar to the secant, cosecant, I think of as sine. So I'm really going to do sine of 45 degrees. So if we go over to this triangle, sine is going to be opposite over hypotenuse, or you can do this angle, opposite over hypotenuse. It doesn't matter. Typically I just kind of put 45 here and I don't even worry about that angle, and then I can get everything I need because it's the same angle. So 1 over root 2. Now normally I would say let's rationalize this, but this isn't the answer we're looking for. We're looking for cosecant of 45. So we want to take this answer and do the reciprocal of it, which is root 2 over 1, which then just becomes root 2. So you'd still get the same answer, but a lot more work. If you rationalize this, you'd have a root 2 over 2, and then you do the reciprocal of it, and then you would take your this square root and put it into the denominator, and then you'd have to re-rationalize everything, but eventually it would simplify to this. So you may not, because your answer's not based off of this one, so flip that one, and then you don't need to worry about any rationalizing. All right, and that was a little bit of an introduction to some special right triangles. There's going to be a lot more that involves this, but these are huge. As long as you can write that down, you're going to be able to do a whole lot of these exact values, even when we start doing things that are bigger than 90 degrees. All right, thanks.